Good morning, everyone, and welcome to 5.4 of IM3. And we will be exploring the different graphing polynomial functions to see what the characteristics of the degree n polynomials functions will look like and how they are related to the graphs. So we're going to be using decimals. So make sure that you have your decimals logged in side by side so you can follow along. So make sure that you have the graphing calculator handy again. So I want you guys to take a look at this first of all and review the polynomial. So let's review the polynomial functions of degree n. So to tell the degree, again, you look at the highest power or exponent that is in an expression. So for example, if there's a number by itself, the degree is considered 0 because there is no variable. But if it's only linear, like, x is the highest degree, that would be, so x has a 1 degree and this number by itself has a 0 degree. So between the two, 1 is higher. That's why this is considered a higher degree. So for a quadratic, this is a second degree, this is 1, and this is 0. So you choose the highest degree, which is 2 in this case. So that makes the quadratic a second degree. And likewise, you keep going. And for a cubic function, the highest power is 3, 2, 1, and 0. So the highest is 3. So that makes a cubic function third degree. And likewise, quartic means it's a fourth degree, and quintic means x to the fifth. That's a fifth degree polynomial. So those are the patterns for identifying the degrees of a polynomial. And here is a common parent function for the linear function. The linear function has a straight line as the graph, and the domain going from left to right is all reals. So the way that we label all reals is negative infinity to infinity. Or you can just use the symbol all reals. This is what I use all the time to represent all reals. The range, when you're going up and down, you notice that the graph also extends like up and down. So it's actually all reals as well. So all reals for the range. End behavior, previously I have described to you how to find the end behavior. As you go to the right hand side and left hand side, so the graph going to the right is going to keep going up. So you're going up to the positive infinity position, and as you go to the left, you looks like the graph is going to keep going down. So we have negative as you go to the left. So those are the end behaviors for a linear function. And let's take a look at the next polynomial, which is a quadratic function. So here's the graph for a quadratic function. Looks like a U-shape, a parabola. The domain as you go left and right is all reals because it keeps extending. The graph does not stop as you go from left to right. There is no point, no lifting of anything. So you are looking at all reals as well for the domain, and that's how you can write it. So either way is fine. The range, notice that there is a stop. The lowest point of this graph, if you're looking at it, is going to be at 0. Okay, that's at the x-axis. So there is nothing below the x-axis. So absolutely empty right here, right? So that's why the graph, the range, is that the graph is above 0. The lowest point is at 0. So that's why it's greater than or equal to 0. And here's another way that you can write it. It includes 0. So you use the brackets from 0 to infinity. Infinity is just the parentheses, but if you want to include the point, you want to use the bracket. So that's how you write it. So anything greater than 0 or equal to 0. And end behavior, as you go to the right-hand side, the positive infinity side, the graph keeps going up. So that's the right-hand side. And as you go to the left, you still keep going up. So it's up and up. And so both positive infinity. And that's for the quadratic. Let's take a look at the cubic function next. And so here's what the graph for the cubic function looks like. The domain is all reals, as we have previously mentioned. And either one of these is fine. And the range is also all reals. So negative infinity to positive infinity. End behavior, as you go to the right, it's going up. So it's going up to positive infinity. And as you go to the left, you're moving down to the negative infinity. So So as you go to the right, it's positive. As you go to the left, it's negative in this case. So that would be the end behavior. Next, we're going to look at the quadratic, which is, the quartic, which is x to the fourth function. And the graph, believe it or not, is going to look like a W shape. So this is the graph for an x to the fourth. And if you actually look at the domain, again, going from left to right, is Oreos. It does not stop anywhere. So Oreos. And then the range is, again, the lowest point you see is at 0. So it's actually y greater than equal to 0. Or it goes from 0 to infinity. Okay? And so we have the end behavior. As you go to the right-hand side, the graph is going up to positive infinity. And as you go to the left, it goes up to positive infinity as well. So positive, positive. Ladies and gentlemen, at this point, do you guys notice any pattern here? So earlier, this is positive, positive for the x to the fourth, but did you guys notice that it's kind of identical, exactly the same? Everything is the same for the x squared function. And you notice that the linear and the cube kind of have the same thing. So that kind of sums it up to an odd function or an even. So the even function, x squared, and x to the fourth have the same kind of characteristics. And the odd functions, which is x cubed and then just x, the linear, have the same characteristics. Interesting concept, right? So that kind of like brings us to our next. So let's see if it follows the same routine for the next one, which is x to the what? Fifth, right? X to the fifth. And this is a quintic function. So x to the fifth. And if you guys actually use decimals, you can kind of see that this graph kind of almost looks almost the same as the cubic function. It kind of looks just something like this. So if we look at the domain, as you can see, going from left to right is Oreos. It keeps going. And it going up and down is also Oreos. And end behavior will also follow the x and the x cubed, which is odd function. So going to the right is going to be positive infinity. And going to the left, is going to be negative infinity. So it's following the same. So again, it kind of follows the same pattern of the odd function. So we have pretty much summed it up to that. And so now I want you guys to go and practice with x with the decimal function to just kind of practice. Go and enter if and see if our theory kind of matches. So enter x to the 6. So enter y equals x to the 6 and see if it follows the 2 and the 4 pattern. Enter x to the 15 and see if it follows the odd like the x cube, x fifth, and then x to the 1000. See if what patterns you. So put a bunch of equations in decimal and just play with it and see if it follows the theory that we have established here. And next, let's take a look at the discussion question. What do you notice if there is negative in front of the parent function? So I actually think that we haven't covered the negative. So what it does is, from what we have previously done, that if you have a function and it says negative, whether it's negative x squared, actually let me just start from the x and then negative x squared, negative x cubed, negative x to the fourth. What does it do? Remember that negative in front causes a reflection across the what? The x-axis, right? So if the graph looks like this, now it's going to be like this for the linear function. If it's a parabola opening up, it's now going to be opening down. If it's a cube going this way, it may be going this way now. And then if it's x to the fourth, it's like a W opening up, it's going to be opening down now. So that is what a negative does to the parent function. So I want you guys to actually enter these equations into decimals and see if that actually follows the theory that we are saying here. And what happens to the domain and range and end behavior. It kind of flips things. So, you can see that domain, it does not change at all for any of the function. It's still Oreos pretty much for all of them. But as you can see that for the range for the odd ones, the range is not going to change because it still covers all reals, right? But the range for the even ones are going to flip. So for the negative one, for the x squared, instead of y greater than or equal to 0 for the positive x squared, for the negative one, it's going to be all of a sudden flipped, which means less than. It's going to be below the x-axis. And then same thing for the x to the fourth. It follows the same pattern. So x to the fourth originally was greater than or equal to 0, but negative x to the fourth is going to be all of a sudden less than or equal to 0. So that would be, and then the end behavior also kind of follows that. So instead of going for the square, it kind of flips for the odd ones. Instead of the end behavior, it's going to be up down. It's going to be down up. So on the left side it flips, right? On the right, so it flip flops for the odd ones, and then for the evens, again it flip flops. So instead of both of them up up, it's going to be down down for the even one. So up up and down down. So that's how the end behavior will be different. And we can go ahead and practice now with the problems that we have with the negatives. So let's go ahead and practice negatives. So go ahead and try and graph this. So this is what the graph would look like for the x squared, right? Negative. So the graph, and then the x cubed, instead of being this way, it's going to be this way for the negative x cubed. And the domain for the it's going to be all reals for the square, and then same thing for the cube. So the range is the one that's going to be different. Remember, instead of above 0, it's going to be less than or equal to 0. And the range for the negative does not change. It stays the same. End behavior for this one is going to be, again, negative infinity and negative infinity. As you go to the right and left is the same thing. As you go to the right, it's going to go down for the negative x cubed. And then as you go to the left, it's going to be going up. So you just need to make sure that you got your directions correct, okay? And so now you can go ahead and feel free to explore some more with decimals and take a look at the different features. And then go ahead and get started with your homework for today. And it's in Google Classroom. So follow the Google Classroom for the homework. Have a nice day.